So to answer this question, I suppose you first have to have a clear sort of concept in your head for what a radian is. So to do that, I suppose I'll start with a object there. I'll start with a circle, right? So okay, didn't work. There we go. Right, what is a radian? So a radian is the angle that's created when you take the arc on a circle equal to 1 radius. So whatever length your radius is, if you then map out that same distance on the arc of a circle, you end up with an angle in here that is known as 1 radian. And you can do that in any circle. You can map out 6 and a bit radians, because the radius always goes into, whatever the radius is, it always goes into the circumference. Six and a bit times. So let's say all of those distances were equal. Okay, now 6 and a bit. Why am I saying 6 and a bit? It's actually 2 times pi. That's how many times, and pi is 3.142 or whatever it is. So 2 times that is 6.284, right? So that's how many. So each one of these, the radius will go into the circumference 6.284 times. And you get radian, a radian, a radian, a radian, a radian, and a 0.284 for radian. Okay, that little bit there, not a full radian. So what does that mean for any arc? So if you look at another circle and shows any arc, okay, sorry, any size arcs, we don't know how big this is. Okay, it's more than 1 radius, but we don't know how big it is. But whatever size the angle is in radians, if we multiply that by the radius, we would get this distance here from here to here. Okay, so radians, so this could be, for example, 1.5 radians. So 1.5 by the radius, 1.5 by the radius would give us this distance here. All right, so you go to answer this question. Do a third circle. So it's a general formula that you're trying to do. In fact, we could have used this. Okay, well, no, we'll do a third circle here. We have an angle in radians. We know that this distance here is going to be the same as that angle in radians. Now it's the angle in radians, not the angle, it's the angle in radians. So it's, 1.4 radians, or it could be 2 radians. So it's the radians multiplied by the radius will give us this bit here, plus the radius there, plus the radius there. So you were asked to write a formula for the radius of the sector of a circle in terms of the perimeter P of the sector, the angle. So what we've got here is write a formula for the radius of the sector, right? So our perimeter, our perimeter, which is from here to here to here, is going to be equal to radius plus theta being the angle in radians by the radius. So P is equal to 2r plus r theta. Factor out the r out. So if you factor out the OR out, you get NOR into 2 plus theta. So what's that giving you? It's giving you for OR is going to be equal to P over 2 plus theta. So that's the question answered. Now I'm just going to develop something here that people may be wondering about. We spent a lot of time in the year talking about pi being equal to 180 degrees and 2 pi being equal to 360 degrees. So why is that? Like, it is and it isn't, right? Pi is still equal to 3.14 and 2 pi is equal to double that, 6.284, okay? But when you're dealing with radians, 6.284 will produce a full rotation in any circle, or pi, which is 3.142, will produce a half rotation in any circle. So we can take it to be 180 degrees, and we can take it to be 360 degrees. When you're dealing with radians, multiplying by this number will give you 180 degrees, and multiplying by that number will give you 360. Every radian is roughly 57 point something degrees, roughly, okay? So I hope that maybe clears up some stuff. We did rush through that at the time we did it earlier in the year, but hopefully that makes sense to people.